All right, let's kick things off with a question that probably takes you way back to elementary school. It sounds so simple, right? But believe it or not, it's at the heart of a surprisingly fierce, long-running debate among mathematicians. So, let me just ask you straight up, is zero a natural number? You probably have an answer locked and loaded from your school days. But what if I told you that the pros, mathematicians, computer scientists, all of them, are actually split right down the middle on this? Because the truth is, there isn't one single universally accepted answer. It all comes down to who you ask. The definition of natural numbers is really just a matter of convention. And that convention can change depending on what field you're in, what country you're in, or even just which textbook you happen to pick up. So the whole debate basically breaks down into two big camps. You've got Team Exclude Zero, which is full of folks like analysts and number theorists. They're kind of leaning on historical tradition. And then you have Team Include Zero, and that's where you'll find the algebraists, set theorists, and computer scientists. They seem to be all about what's useful right now. Okay, so let's dive into that first perspective. Why do so many people dig their heels in and say that natural numbers have to start with 1? Well, it looks like their arguments boil down to history, language, and, just plain old gut feeling. And this right here is probably the most common argument you'll hear. It's super intuitive. The natural numbers are called that for a reason. They're for counting natural things, stuff you can actually touch. You count 1 apple, 2 apples, 3 apples. You never start by saying, I have 0 apples, right? And if we dig a little deeper, we find a few key points backing this up. First, there's the historical argument. The whole idea of 0 as a number is actually pretty new. Ancient mathematicians got by just fine without it for a long, long time. Then there's the language side of things. In some places, like India, they just give it a different name to avoid the confusion. The set 1, 2, 3 are the natural numbers, but 0, 1, 2 are called whole numbers. Easy. And finally, there's a really practical reason. For mathematicians called analysts, who work with things like the sequence 1 divided by n, leaving 0 out just makes life simpler. It completely avoids that pesky problem of dividing by 0. Yeah, and I love this little anecdote that just nails the intuitive argument. I mean, think about it. If you asked a friend, could you go to the store and buy 0 eggs for me? They'd look at you like you're crazy. It just sounds completely absurd in everyday conversation, and that's a really powerful point for Team Exclude. All right, so let's flip the coin and look at the other side. For a lot of modern fields, leaving 0 out isn't just annoying, they think it's straight up illogical. Whoa, okay, this quote just turns the whole traditional argument on its head. The most natural of all numbers? How could 0 possibly be the most natural? Well, it turns out the answer is buried in the foundations of modern mathematics. See, from a set theory point of view, numbers are all about describing the size of a collection of things. So the number 3 tells you there are 3 things in your set. But what about a set with nothing in it? The empty set. What number describes that? It has to be 0. Then you've got computer science, where almost everything, arrays, lists, starts counting from 0. It's the natural starting point. And for the algebraists, well, including 0 is absolutely essential for building a nice, clean, consistent system. And this really gets to the core of why algebraists love 0 so much. There's this idea called a monoid. Just think of it like a neat little toolkit. You've got your set of numbers, you've got an operation like addition, and you have a special identity element. That's just a fancy way of saying a number that doesn't change anything when you use it. With addition, what's that number? It's 0, of course. You add 0 to anything, and it just stays the same. So when you include 0, the natural numbers become this perfect, elegant, complete system. Without it, it just feels like there's a crucial piece missing. So, okay, we've got two really strong, really compelling cases here. On one hand, you have tradition and the simple, intuitive act of counting stuff you can hold. On the other hand, you have the logical consistency and beautiful structure that you absolutely need for modern math and computer science. So after hearing both sides, who do you think wins? Which argument feels more convincing to you? Is it the common sense, we're just counting things argument? Or is it the elegant logic of the empty set and those neat algebraic structures? Well, here's the twist. The answer is, that's the wrong question to be asking. Trying to pick a winner here completely misses the point. This isn't some debate that one side is going to win with a final killer proof. The reality is, both definitions are correct. They're just correct in different contexts. We tend to think of math as this process of discovering some single objective truth, but sometimes it's more about creating useful and consistent definitions that get a specific job done. And in this case, the job you're doing determines which definition you use. And this quote just nails the pragmatic heart of it all. The choice to include or exclude zero, it really just boils down to what's convenient for whatever you're working on at that moment. Writing a theorem about how big sets are, you're going to want zero in there. Working with those 1/n sequences, you'll probably leave it out. It's really as simple as that. So here's the real kicker. Professional mathematicians and computer scientists, they don't actually sit around arguing about this. Why? Because they came up with a simple, really elegant solution to avoid the whole mess in the first place. They just don't use the ambiguous term natural numbers if they can help it. Instead, they use language that's way more precise. If they mean the numbers that start with 1, they say positive integers. If they mean the numbers that start with 0, they say non-negative integers. They even have specific symbols for them, so there's absolutely no confusion. They just sidestep the entire debate. And that right there is the real takeaway. When it comes to math and science, being crystal clear is everything. So let's just end on this thought. This whole debate, it kind of reveals something fascinating about math itself, doesn't it? We're taught to think of math as the ultimate source of objective, capital T truth. But if something as basic, as fundamental, as our counting numbers can be defined in two different ways, purely for convenience, well, maybe mathematical truth is a little more like a human invention, a powerful language we've built to describe the world, rather than some pre-existing landscape we're just discovering. What do you think?